Okay, next we have aiding of electromagnetic wave by phasor. What is a phasor? First we will define it. A rotating vector of magnitude E naught. Let's say this is the magnitude of a rotating vector which rotate in anticlockwise direction is called phasor. Consider two electromagnetic waves at point P in the single slit experiment and the double slit experiment, Young double slit experiment. Suppose we have two vectors at point P. One is R1 and the other one is R2. This is magnitude E1. This vector is represented by E1. Its magnitude is E naught. And this is magnitude vector E2. And it is also magnitude E naught. This E1 is given by E naught sine omega t. And E2 is given by E naught sine omega t plus phi. These are two vectors. They have same magnitude but they have different phase vector. This is the called phase vector. Now in these two vectors, E naught gives the magnitude and omega t for this vector or omega t plus phi for this vector. It gives the direction of the two vectors. Gives the direction. Because if we look at here, both these vectors have different directions. The direction of this vector is different from the direction of this vector. Its direction is given by this one. Its direction is given by this one. Now, the wave with component E1 and E2 are given by phasor, are represented by a phasor of magnitude E naught. Suppose we have two vectors which I represented here. Let's suppose this is E1. Both these vectors have a magnitude E naught. This is a magnitude E naught. This one also has a magnitude E naught. Means both these vectors have the same length. This vector makes an angle omega t with this x-axis. Let's suppose with this axis, and this vectors makes an angle phi here. So its total angle is omega t plus phi. Now, if we take the projection of this vector on this axis, this is E1. If I take the projection of this vector on this axis, then this is E2. This is E1, this is E2. So E1 is the projection of this vector with magnitude E naught on this axis, and E2 is the projection of this vector with magnitude E naught on this vector. Now, the wave with component E1 and E2. are represented by phasor of magnitude E naught because they are moving anticlockwise direction and they are rotating because this is angle omega t and this is angle omega t plus phi, and this angle is anticlockwise. So they are represented by this phasor E naught. They rotate around this origin at angular speed omega. Now the value of E1 and E2 at any time are the projection of this phasor on this vertical axis. Now the phasor E1 has a rotating angle omega t and the phasor E2 has a rotating angle omega t plus phi. Now to calculate the field components of these two vectors E1 and E2 at point P, this is point P, we are adding these two vectors vectorially. Suppose this is vector, this one E naught, which means makes angle omega t, and this is the vectors, this one, this vector with magnitude E naught. It makes angle with this vector is phi. So the resultant vector is given by this one. This is the resultant vector E. Now if I plot a perpendicular from here, then this is 90, this is 90. I call this angle as beta, and also I call this angle as beta. If these are beta, then this part from here to here, from this right angle triangle, from this right angle triangle, this part is E naught cos of beta, and this part from here to here, it's also E naught cos of beta. I can represent it more clearly. This is E naught cos of beta, and this part is also E naught cos of beta. Now this total vector, this one E, which is equal to the sum of these two from here to here and then from here to here. So this is E naught cos of beta plus E naught cos of beta. This is equal to 2 E naught cos of beta. This is E. Now if we look at here, the two angles, this beta and this beta, they are equal because they are opposite angle of equal length side, because this length is same, this length is same. So this length is also same. So it means that this angle will be equal to this angle. If this is the case, then we have a theorem that an interior angle, like the exterior angle, sorry, this angle phi, this angle is phi. This exterior angle will be equal to the sum of the two opposite interior angle. The theorem is the exterior angle phi is equal to the sum of two opposite interior angle, beta plus beta. So this is the interior angle phi, which is equal to the sum of two exterior angle, beta plus beta. Now from this we can write 2 beta is equal to phi, or beta is equal to phi divided by 2. If I put the value of beta here, then E will be equal to 2 E naught cos of phi divided by 2. Now taking square of both sides, we have E square is equal to 4 E naught square cos square phi divided by 2. Now, as we know that the intensity of electromagnetic wave is proportional to the square of its amplitude, because in the previous case we consider a square is equal to intensity and a prime square is equal to maximum intensity. So the intensity of electromagnetic wave is proportional to the square of its amplitude. Now the wave with amplitude E naught, is intensity I naught, and that is proportional to E naught square. So this equation can be written as this will be equal to I square, which is equal to 4 I naught square cos square phi divided by 2. Where I square is equal to E square and I naught square is equal to E naught square, because intensity is proportional to square of the amplitude of the wave. So these are the amplitude, E square and E naught square. So this will be I square and this will be I naught square. Now if I put the relation, we know that the relation between phase difference and path difference, because we know that the phase difference is related to the path difference by a factor 2 pi over lambda. Now phase difference we normally represent by phi, which is equal to 2 pi over lambda, and we know that path difference is delta L. But we already know that from the double slit experiment that delta L is equal to d sine of theta. So if I put it here, phi will be equal to 2 pi over lambda d sine of theta. So our final expression, this expression can be written as I naught I square is equal to I naught square cos square phi divided by 2, and phi is 2 pi over lambda d sine theta divided by 2, this one. We can write it as I square is equal to I naught square cos square phi divided by 2, where phi is 2 pi over lambda d sine of theta. Now for maximum intensity, if I look at here, we have two expressions now. We have two expressions, and the two expressions are I square of the intensity is equal to 4 I naught square, and we have cos square phi divided by 2, where phi is 2 pi over lambda, and we have d sine of theta. Now intensity will be maximum if this part is maximum, and this part is maximum if this value, this cos square phi by 2 has maximum value. And we know that cos square phi by 2 has maximum value only if phi divided by 2 will be equal to m pi. Like if I put phi by 2, if I replace phi by 2 by pi, 2 pi, 3 pi, 4 pi, 6 pi, then we have this quantity has a maximum value. Its value will be 1 for this value. But we know that phi by 2 is 2 pi over lambda d sine theta is equal to m pi. Pi cancel with this pi, so d sine theta will be equal to and we have also yes this is 2 here because pi is 2 pi over lambda d sine theta divided by 2 is there, so 2 cancel with this one, so d sine theta will be equal to lambda, and this is the condition for constructive interference. So it means that the intensity will be maximum if there is a constructive interference, and the intensity will be minimum. By minimum means zero intensity occur only if this term is 0, and this term is 0 only if phi by 2 is 2m plus 1 lambda by 2, or phi is equal to 2m plus 1 lambda. But we know that phi is given here 2 pi over lambda, 2 pi over pi, sorry, or I can say that, yes, just a minute. For minimum intensity, this cos square phi by 2 will be equal to 0, and this is possible only if phi by 2 is equal to 2m plus 1 pi by 2. Like if we have pi by 2 is pi by 2, or 3 pi by 2, or 5 pi by 2, and so on. Or from this we get phi is equal to 2m plus 1 pi, and we know that phi value is given here, which is 2 pi over lambda d sine theta, which is equal to 2m plus 1 pi. Now pi cancel with this pi, so d sine theta is equal to 2m plus 1 lambda by 2, and this is the condition for destructive interference. Because the path difference is odd multiple of lambda by 2, and there if the path difference is odd multiple of lambda by 2, then the two waves reaches to point P will interfere destructively, and we have a dark spot here. If it is interfere destructively and we have a dark spot, then the intensity will be minimum. So this is all about addition of electromagnetic wave by phasor. Thank you.